Hey friends, how are you? I hope you are absolutely fine. And I am Pratham. I am here with my YouTube channel, Learn with Pratham. Today I will talk about very well-known machine learning algorithm, that is basically a clustering algorithm. And you already know about the thing that clustering algorithm is nothing but unsupervised learning. So we'll talk about today, that is basically DBSCAN clustering. What is DBSCAN clustering? That is density based spatial clustering. For the spatial data, we particularly use this density based clustering. And what is density? Density is nothing but number of points divided by area. So in physics, you have already learned about the mass divided by volume, and the basic intuition behind this is nothing but pretty same over here. That is number of points divided by area. So over here, in order to know about this DBSCAN clustering, just we have to know about three terminologies. That is, first one is the core point, second one is the border point, third one is the noise. So what is core point? Core point is in a circle of radius epsilon of center C, if number of points greater than equals to k, that is, what is our k and epsilon? That is, k equals to number of minimum point and epsilon is the radius. Okay, so why epsilon basically, uh, you know in a particular circle, how many points are there? Say for you do have a circle, and how many points are there? So if this particular circle is dense, okay, then what is the center of this particular circle? Then this particular center is a point, and this point will be considered as a dense point. That is basically a core point over here. So go through it in the circle of radius epsilon of the center C and number of points greater than equals to k, and you know so you have defined there should be a circle and number of points over there greater than equals to 3, and then the center of that circle will be considered as the core point. Say you have defined over there that k equals to 3, then that will be defined as the core point. If the point is not core point, either it will be a border point or a noise. When it will be a border point? In the circle of radius epsilon of the center B, let us suppose now the center is B, and if the number of point less than k, k is your minimum number of points should be there in a circle, and that number is less than k, and one core point is there in the circle. There should be one core point is there in the circle, then B is a border point. If the point and you have drawn a circle that is not satisfying the condition of the border point and not satisfying the condition of a core point, then it's a noise. Okay, these three terminologies are there. Okay, so we have to know about these three terminologies, and you have to know about the mathematical definition of these three terminologies. And now what is happening over here, for a particular example we will see. Then from this particular example, just we will try to define that what is a core point and what is a border point. So let's start. Say you do have the points 1, 2, 3, 4, 5 and 6. Okay, so now say, and you have drawn a circle with a center of 1. Okay, and your for this typical example, say you do have these parameters. What are the parameters over here? K equals to 3, number of points, minimum points, that is equals to 3, and epsilon equals to 0.4. Okay, so what epsilon is 0.4 is nothing but the radius of that particular circle. So you have drawn a circle of radius 0.4 of 1, and you have drawn one one circle with a center of 2, in center 3 same radius, center 4 same radius, center 5 same radius of the circle, and center 6 also the same radius of the circles. From here, and let us suppose and you over here, just from a pictorial view, what is there? That is nothing but with, say, for 1 there is a, just you have drawn a circle and 2 is there in the circle. Okay, so number of points are there in, in this particular circle is nothing but 2, and over here for this particular circle number of points are there in the circle, that is 3, and for this also 3, for 4 that is also 3, and for 5 that is 4 and 5 is there, and for 6 that is only 6 is there. Okay, so we have to find that which one is the core point, which one is the border point, and which one is the noise. Okay, so let us suppose, if you let us say, just from all these points, let us suppose they are connected. Okay, all these are connected, so like this, all are connected. So from 1 to 1, what is the distance? That is 0, 2 to 2, all these diagonals will be 0. And from here 1 to 2, 2 to 3, 3 to 4, 1 to 3, 1 to 4, 1 to 5, 1 to 6, all the distance matrix we will have. Okay, so from here we have to find which one is the core point and which one is the border point. Okay, so fine, let us start from point, let us start from 1. Okay, so let us put all these value over here, otherwise it will be pretty tough to compute. That is 0.4, okay, so 0.4 to 4, that is 0.6, that is 1.2, that is okay, 5 to 2 to 6, so 2 to 6, 5 to 1 is 1, 2 to 6 is also 1, and 5 to 3, that is 3 to 5 is 0.5, and this is 0.3 again, and 0.45, and this is 0.7, and this is 0.9. Okay, cool. So from here, let us suppose let's start with 0.1. This is your 0.1, this is 0.2, 0.3, 0.4, 0.5, 0.6. Okay. So from here, 1 for 0.1, how many values are there in the column, or you can take this row or this column, everything is fine because this is a symmetric matrix. How many values are there in this column less than 0.4? That is nothing but only one value. So then this will be either a border point or a noise, for sure. This is not a core point, because if so, how many points are there in this circle? That is, one itself is there, and another one is the 3 in 2, 1 and 2. So how many values are there less than 0.4? That is 0 and 0.3. That is that is less than k. That is nothing but less than 3. That then it will be either a border point or a noise. Okay. So let's focus on this particular point, that is 2. So how many values are there? 0.3 is less than 0.4, 0 is less than 0.4, 0.2 is less than 0.4. Okay, so that is a core point, because number of points in this particular circle is greater than 3, greater than equals to 3. That is greater than equals to 3. Okay, so let's consider this 0.3. 0.3 is nothing but this is less than 0.4, this is less than 0.4, again this is less than 0.4. So this is also a core point. Now let's consider this 4. Okay, so this is less than 0.4, this is less than 0.4, this is less than 0.4. So this is again a core point. Now let's consider this one, less 5, and this is 6. So what will be 5? 5 will be nothing but, so how many points are there? Less than 0.4, that is this one and this one. So that is 2. So that is less than 3. That is not, then it will be either a border point or a noise. And again over here you can find that this is, so sorry, this is not less than 4, only this one, this 0 is less than 4, then this is also a border point or a noise. Okay, good. So now we have already found that these three is a core point and these three are either a border point or a noise. Okay, cool. So this, now focus on this particular point 1. Okay, so point 1 is connected to 1 and connected to 2. So, and we don't know 1 is core, border point or a noise. We already know that 2 is already a core point. So if it is a core point and number of points are there in the circle less than k and it is also connected to a core point, then it is a border point. Now let's focus on 5. 5 is connected to 5 itself and connected to 4. Is 4 a core point? Yes, 4 is a core point. Then it's a border point. Now let's consider about 6. 6 is only connected to 6 and that is not connected to other, in this circle there is no other point, so that is not connected to any core point, so then it is a noise. So now, so in this particular cluster, so you can find only these points will be considered as a cluster and this will be considered as a noise. So you have already found this algorithm over here and I think this is pretty decent to understand, and you have already you are already known about the thing that this is with the help of this DBSCAN algorithm we can detect the anomaly, detect the noise over here. So this particular algorithm is pretty intuitive, and with the help of this algorithm you can perform the clustering for the spatial data, and this is very useful. I hope you have enjoyed the video. So stay tuned with my channel and just press the bell icon, hit a like button and subscribe my channel. And right now, bye bye. I'll be there with you in the next video. Thanks.